So, if the crust of Venus would have been thin enough and brittle enough for plate tectonics, if only liquid water oceans had formed and helped set up a plate tectonics with a CO2 cycle in an ocean like on Earth, well, could it be that water oceans once existed on Venus? Indeed, since the most common gas expelled by volcanoes is H2O, the volcanoes on Venus should have put out a tremendous amount of H2O just as well as they put out a tremendous amount of CO2. And yet the atmosphere of Venus contains hardly any H2O, and the rocks are dry. Where is the water? Well, on Mars, H2O molecules are broken apart by bombardment with particle wind and ultraviolet radiation from the sun. What if the same thing has been happening to the H2O molecules on Venus? And that after the H2O molecules are broken apart this way, the pieces then are lost to space by more easily escaping Venus's gravity. Well then, what does remain behind should disproportionately consist of heavier isotopes of hydrogen and oxygen. Indeed, with heavy hydrogen, hydrogen-2, also called deuterium, we have a direct measurement of the atmospheric gas that confirms that this is indeed the case. The amount of heavy hydrogen in the H2O that does exist in the atmosphere of Venus is enormously larger than the amount of heavy hydrogen that exists here on Earth. So that is direct evidence that Venus has been losing its H2O molecules in this way. So, what happened? Maybe there was liquid water even before a runaway greenhouse effect occurred. An ocean of liquid water might have gotten so warm that it started to evaporate too much. Recall that water vapor is a greenhouse gas, just like carbon dioxide is a greenhouse gas. So more water vapor in the atmosphere causes more greenhouse effect, which warms the atmosphere further, which, if you have a liquid water ocean sitting on the planet's surface, would mean more evaporation off of that ocean. Even more water vapor means more greenhouse gas, means warmer again, and this is a positive feedback loop, and it turns into a runaway. Past a certain critical point, the oceans would completely boil away. So, could Venus have been cool enough in the first place to have ever had a liquid water ocean? Well, yes. Recall that our sun was as much as 30% to 40% less luminous 4.5 billion years ago when the sun and planets first formed. Our sun has been increasing gradually in luminosity ever since its birth. The slide shows a little reminder to you of exactly what is going on inside the sun that causes this gradual increase in luminosity, but for all the planets in the solar system, they have had to deal with slow and gradual warming of their climates due to the sun gradually brightening. On Earth, there was more CO2 in the early atmosphere that led to a stronger greenhouse effect that made up for the weaker sunlight. Venus probably started out very similar to Earth, and during the time when the sun was weakest, maybe the first billion years or so, it might have had liquid water oceans. But then the sunlight continued to increase, and it just became too much. In this way, our sun brightening maybe 10% per billion years, we figure that the Earth too is going to lose its oceans. Perhaps in only another 1 billion years, some calculations say just 500 million years, the sun will have brightened so much that even if there were no greenhouse gases around the atmosphere of the Earth at all, it would simply be too hot to prevent the runaway greenhouse effect produced by Earth's oceans evaporating, and they would boil away. The cosmic perspective on this is interesting. Life has been on this planet for nearly 4 billion years. And yet, it may not last 1 billion more. So I hope I've given you a feel for how important it is to understand Venus. It tells us a lot about Earth's probable future. It tells us a lot about just how sensitive and delicate the entire system of what goes on Earth's surface is, to even the slightest change throwing it so out of whack that it completely changes everything. And yet, as I've said before, Venus is one of the most poorly understood of the terrestrial planets. Truly, more research on this planet is needed in the 21st century. Thank you for listening to my video makeup lecture. I look forward to seeing you all in class very soon.